topic that stands at the heart of modern urban development, demand-side management in smart cities. To enlighten us on this significant subject, we are honored to have with us Mr. Benet George, Principal Consultant at Bigeta Energy Solutions. Mr. Benet George is a BEE accredited energy auditor with over 21 years of rich experience spanning ESG consulting, energy efficiency projects, solution development, measurement and verification, project management, and training. His professional impact is global, having successfully executed more than 700 energy projects across 11 countries. He is also one of the 4 CEMI trainers in India, contributing significantly to energy management training nationwide. His excellence has been acknowledged with several recognitions, including the SEAM National Energy Management Award for star performance in the Energy Auditor category 2023. Academically, Mr. Benet holds an MTech in Electrical Engineering from NIT Calicut and a postgraduate diploma in Electrical Safety and Safety Management. His professional credentials are equally impressive. He is a certified energy manager and auditor, a CEM international trainer, a certified measurement and verification professional, a project management professional, and a fellow of the Institution of Engineers, India. Before founding Bigeta Energy in 2017, he served in various global roles at Schneider Electric, contributing to major measurement and verification projects, including a single project valued at $1 million over 3 years. He also has a strong academic background with 4 years of teaching experience as an assistant professor, during which he taught core engineering subjects and coordinated the industrial interaction cell. Sir, we are extremely delighted to have you with us today. I now warmly invite Mr. Benet George, sir, to deliver the session.
Thank you so much for a warm welcome. Now we have 68 members there in the platform. I think there were around 82. Maybe few of the people may be joining. We may wait another 1 or 2 minutes. We'll start at sharp 7:40. But I am sure that we will not exceed that time. We'll complete within the stipulated time. And in between, if anybody wants to ask questions, you can either put it in chat box. I'll also looking into chat box. Or if anybody wants to have an immediate attention, you can unmute yourself and ask questions even in between. We'll try to manage the time. Yeah, great. And just want to know whether the most of the participants are from electrical department or electrical background, or there are people with a different academic background.
Most are from electrical background, sir.
Great. Okay. Yeah, it's 7:40. So I know this may be a very long session for you today after your working hours. Now maybe another 1 hour, 20 minutes we have a short session. So it was quite interesting session, even the previous topic in the EV vehicles. And we know that our solar generation is increasing, so it also create lot of pressure in the grid as well as in the local network. So I strongly believe this topic is very relevant, especially in the current scenario. So we'll start from the very basic in the necessity of demand side management, the type. And later, I'll give you a real example, a case study. So that is how it is structured. So we have 69 people. How many of you really think climate change is real? You can put in chat box, or you can put maybe a hand raise or thumbs up in your chat box. Let's have some interaction during this session. Nobody? How many of you really think, okay, this climate change will really affect each one of us? I think there is no response. Probably I'll cover. See, if we think, okay, it won't affect us, this is some of the pictures, image, and news which gathered from various sources. You can see the extreme temperatures, wildfire, lot of flood, cyclone. These all are the various news which we see every day, including today. We may be able to see, okay, there are flood in Chennai. And it is not only the images or news. The statistics says in India climate 2025, 99% of the days in January to September experience extreme weather, and which resulted 48% increase in the casualties and crops damaged by 400% in 4 years. So that means this is going to affect everyone in current scenario. It is not in the future. So this demands an urgency of climate action. So people, many of you may be knowing, okay, the 1.5 degree which was targeted. But you can see here in 2023 itself, in the emissions rose by 1.3 degrees Celsius, the average temperature. So we don't have time, but we have to just act on these issues. So this is the scenario, or this is the background of the demand side management. So by seeing this, every country is having some of the plan. Even India is having a plan to become net zero by 2070, and we have high target of solar generation, and which we have achieved much in advance. So the decisions one we make today will define the livability of tomorrow. So that is one of the quote by Barack Obama. We are the first generation to feel the effect of climate change, and the last generation who can do something about it. So that means if we are not acting, the time, and this may be the last option or the last chance. So that is the background. By seeing this, we can see here in India scenario, in the energy generation is increasing, the demand is increasing year by year. So that is the statistics stays. And when you see here, the industry contribute the major, followed by the transport, and then others and non-energy use. And you can see here everyday news, the large industries coming across the various part of India, and large townships are coming across India, and lot of EV vehicles are coming every day. So this actually demands more and more energy generation, and as a country, our per capita energy consumption also increasing, even though it is much below than many of the developed nations. So this gives the share of electricity. Now, if you see here, you can see here this color, the share of electricity is actually increasing in all consumption. When you talk about electricity, earlier time, the fuel we're using, maybe the petroleum, diesel, or other fuels like coal. But gradually, when you're shifting from IC engine to electric vehicles, our usage of electricity is increasing. So we can see that gradually, maybe 2050, we will reach 30% of total energy may be used for the electricity as a final consumption. And you can also see the increase in the energy consumption. So that means the demand is increasing day by day, which is inevitable. The reason is, as a country, many of the people are not having electricity today. And as a country, we have to have roads, industries. So it is quite essential to have a lot of electrical energy generation. So this gives again in the sector-wise consumption in the industry, agriculture, domestic, commercial. So that means there are potentials or there are areas where we have to act, we have to work on that to reduce the energy consumption by keeping in the growth in track. So it is not new. So there is a national action plan on climate change, which is having 8 missions out of national solar mission people may be knowing. And there is one mission called a national mission on enhanced energy efficiency. Under that, there are many programs in national mission on enhanced energy efficiency. There are many programs. There are programs to reduce the industrial energy consumption. It is called the PAD scheme. And there are other programs called agriculture demand side management, municipal demand side management. These programs are maybe running quite long back, say from 2010 or even before. So I had opportunity to work the early stages of these projects, many of the projects, including municipal demand side management of many of the cities in Kerala and other part of the country. So you can see here the Bureau of Energy Efficiency under various programs doing various activities to reduce the demand or energy consumption. It may be one of the program people may be knowing Ujala, or people can know, okay, LED program. So when we think about LED, it is a large scale program. When we think the LED was the price range of say something like 300 to 400. So the Bureau of Energy Efficiency along with the EESL could reduce their price to less than 50-60 rupees. So by that, as a country, we could able to save 53.6 million tons of oil equivalent in the year 2023 to 2024. These are the verified numbers. Out of that, almost 51% comes from large industries, around 1,000 industries, comes under PAT scheme. Remaining 29% comes from the LED program, which is the nationwide program. Then standard and labeling, people may be knowing a 5-star label items, etc. Then this 1% comes from street light national program. Then this is the accelerated vehicle, electrified vehicle program that is comes under. Then others are coming 1%. That means there are a lot of activities happening in the demand side management or energy efficiency in the country. Then in demand side management, finally, we are trying to manage the demand. It may be the reduction, it may be the shifting, or it may be other activities. Typically, it starts with a load research. That means it can be what will be the future load pattern, the current load pattern. So for example, when we are having an accelerated EV program, how it will impact the demand in the grid, that is studied. Based on that, a potential assessment will be done. For example, when we have electrical vehicle, now all this electric vehicle, it is not having a capability to give back to the grid or to the home. So now, maybe in future or some of the other countries, there are vehicles which can store the energy and it can pump back to the system when it is not in use. So a load research based on that potential assessment, it may be to how the capacity utilization or limiting or flattening the curve. Then based on that, what is the cost effectiveness? At the end, whatever investment is done, it should have a good return on investment. So that cost effectiveness assessment is done. Then based on that, a design of demand side management program is developed. Then it may be implemented in multiple ways. It may be nationwide program, or it may be utility scale program, or it may be community based program, or it can be even in the individual based or household based program. Then how the success of that program, it is not only in the implementation. For example, what are we seen in the previous slide, the energy saving, what we are seen in the previous slide, that was taken by monitoring and verification of this DSM, demand side management. Then it is reporting the results and saving. This is the overall steps in the demand side management projects. So this is a load curve of BESCOM, Bangalore Electric Supply Company. In you can see here what are BMAS, BIRAS, CETAs and all. This is a different regions. You can see something like a different districts in the Bangalore area. And when you see here from 0 to 22 hours or the 24 hours, in the peak consumption, Bangalore is we can say it is an IT hub. There are a lot of IT facilities. So during the daytime, or a lot of commercial activities. So during the daytime, the demand increases considerably. So okay, I can see here from 6,000 megawatt, it is going up to 8,000, 8,500 megawatt. And when you see further industrialization or further even IT facilities or another job creation, that means this daytime load may go further increase. When this load increases, it requires further increase in the generation capacity, transmission capacity and distribution capacity. The capacity of transmission lines, distribution lines, as well as the transformers, etc., needs to be assessed. Then second is, as a state, Karnataka is having large solar power stations. So many of the days, in the almost 80% of the energy is coming from solar power, 80% of the total energy. So that means during the daytime, the generation is very high, which may not be utilized full day. So there's a requirement. We have generation. If we are not able to utilize that generation, we are losing the capacity. So there is a requirement. Either it can be in the load shifting or the managing or the reduction. So this is the requirement of typically a demand side management program. And same may be applicable even panchayat level or the district level or even state level and the national level. So various programs may be done. So these are the different methods of the demand side management. So basically, you can see here it is a peak clipping curve. That means you can consider in the Kerala scenario some of the time. We had water some of the time, but we did not have installed capacity. So during the peak time, there was a load shedding. So that is something like a peak demand clipping, the curve clipping. So we are trying to meet whatever the installed capacity or the maximum what is the peak it can deliver. So we are trying to maybe do curtail some of the load during that period. Then some of the case we are trying to utilize or we are trying to fill the valley. So where the lower utilization is there, we are trying to shift this so that we get more uniform. The load factor will get increased and we can utilize the capacity better. And third one is load shifting. We are trying to shift the load. So maybe from the peak period. So load shifting, the very simple example is that TOD tariff, which actually encourages to shift the load. The time of the day tariff, where maybe 6 to 10 p.m. the charges are high, typically 1 to 2 rupees high. And late night, probably it may be the 1 to 2 rupees low. So it is indirectly encouraging people to shift their load and manage the demand. Then third one is the strategic conservation. Here it can be an energy efficiency measure. It can be demand side management program like LED program or street lighting program or municipal demand side management in the pumping system modification with the efficient pumping. See, this all will come under strategic conservation. Then some of the case load growth curve. So it is a planned curve. Okay, some of the area load is low. So when the town planners, when they're planning, they may be planned to utilize that capacity, and it can be a load growth curve. So this is that, and there is a flexible load curve. So these are the various DSM methods which is utilized for the demand side management. For example, in peak clipping curve, it can be load shedding or it can be demand response. Demand response, the large industries, they will have an agreement with the utility company. If there's a requirement, they may cut, say, 500 kilowatt of the load. So, but they get an incentive for cutting that 500 kilowatt load. So that is a demand response. So these are some of the DSM activities which, yeah, if you have any question, you can raise. Somebody has raised the question, hand. Okay. So one is the awareness generation and energy audit. So energy audit, what it is typically doing, for example, in Kerala, it is mandatory to do energy audits for HV consumers once in 3 years. So indirectly what they are doing, they are trying to reduce the energy consumption of the each industries, which will further help to reduce the overall demand of the state. Second, the one large scale successful program, we can say that it is a BLY, Budget Lamp Program, or Budget Lamp Yojana. It's almost 400 million lamps were replaced with the LED lamps. Then agriculture demand side management program, there are a lot of agriculture pump with efficiency even less than 20%. And these pumps are running 8 hours, 9 hours in a day. So there are various programs which is helping them to replace their pumps with high efficient pump. So basically a pump with the 20% efficiency, we are able to change that with, say, a 60% efficiency, we are going to consume 1/3 of the energy. That means another 2 people, we will be able to give the same power with the same capacity. Then there are other programs running like a ceiling fan or AC, high efficient AC or 5-star rated AC. So these are some of the programs running as a demand side management. Then solar water heater program, for example, in Karnataka, it is mandatory to have a solar water heater to get an electricity connection if it's an individual house with the 600 square feet, or if it is constructed in 1200 square feet, it is mandatory to have a solar water heater to get an electricity connection. So this is also a demand side management activity. Then there are thermal energy storage, which may utilize the energy during the off-peak hours. Thermal energy storage programs were quite running in many of the like shopping malls and all. So shopping malls, you know that, okay, typically evening there's a peak. So to meet that peak demand, like 6 to 10 in the peak demand, they have thermal energy storage. The chiller generate the chilled water and store that, maybe going to the little lower temperature and use that energy during the peak time. So they are able to save that 1 rupee extra, which is we are avoiding that during the peak period. And also since they are avoiding during the peak period, they almost get 2 rupees benefit for each kWh they are consuming. Even considering, say, 80% of 85% of the energy conversion losses, still they have a financial benefit, not in terms of energy, but in terms of financial benefit. And also in terms of demand, grid will be able to get benefit because some of the load, large load, they are shifting to the off-peak period. Then demand response, this is one of the highly attractive program, but not very common in India. But a few of the programs were done in Bombay Electricity Company, where large industries or large commercial building, they will have an agreement with the utility company, like Kerala State Electricity Board. Then in case of a specific demand, they'll give a short notice. Within that short notice, they will cut, say, 500 kilowatt of the load. And it can be 2 ways, one direct. In direct system, it is connected to the utility through like WAN as well as the other IoT devices. So from utility, they will be able to cut some of the load, predefined load, as part of the demand response program. Second, it is indirect or manual method. In indirect method, they will intimate, they will call or they will intimate the user to cut whatever the agreed load for a short period. So what will happen? This will help to manage the peak demand so that they have a capacity, generation capacity. So when it is reaches to the generation capacity, they typically try to do demand response. So that is direct and indirect. Or we can say in some of the cases, unintimated or a sudden power cut in many of the places. That is also we can consider as a demand response, especially not informed in advance when capacity of the line or the capacity suddenly increases. Then that is a power cut is also a demand response program. So these are the various demand side management activities which is actually doing in cities as well as in the other areas. But why cities? It is quite important. In cities, the number of household per square kilometer is quite high. So the energy intensity is quite high in cities. So that in the capacity utilization, many of the cities, the vertical growth, multi-story building, 20 floor or 25 floor building, when it comes in very short area, when we consider per square kilometer, the energy demand is increasing even exponentially comparing to non-urban area. In urban area, this is one of the challenge. So that the electric system should be able to handle this high demand. So this is the sum of the program. So second one, all these programs need to have evaluation, measurement, and verification of demand side management, demand response program. Why it is essential? To understand whether this programs is actually delivering the desired outcome. Second, in demand response program, in the financial benefit to be transferred to the user so that it should be measured. And in the main purpose is the accountability of the impacts. Did the program deliver its estimated benefit? So when, as a country, we are investing money on some of the programs, say it may be an LED program. So we have to see whether it is actually delivering in the expected result. Second, it also helps to risk management to support the energy resource planning. So when, for example, there is a urbanization is happening, there is a forecast. This is the energy demand for that particular area. So when you consider, okay, this means another 100 megawatt is required for a particular area, then the first priority, people will think, okay, whether the existing system can handle that, or if additional requirement is there, how we'll manage, or is it a possibility we can reduce some of the existing load so that we can release that capacity for the future demand. And third one, when you start measuring and monitoring, it also gives an opportunity to improve the performance. So it is a continuous improvement that can be only happen if we measure in the performance of the demand side management, demand response programs. So this is why this measurement and verification, or evaluation, measurement and verification, is quite essential. So this is the some of the categories or what is evaluating. So one is the impact. One is energy or a demand savings. For example, in a panchayat, it is distributed maybe a 10,000 LED lamp of a particular wattage, which was supposed to replace a incandescent lamp of say 60 watt. Then there is a expected reduction. Then whether this really happened or not, we have to see that is the impact. So one is the direct impact, energy reduction, and non-energy benefit also can be there. Okay, there can be, because demand is increased, there may be distribution losses also may came down. Second, we have to see how the process is done. For example, it may be distributed, some of the program, it may be LED may be given in advance, and in the cost is collected from each consumer by in 2 or 3 months time. Then whoever is collected, whether they actually implemented or they actually replaced the lamp or not, it has to be checked. So how is the program is designed? Who is actually going to supply? Who is actually collecting this, and who is administering? And what is the participant response? This program or process success also to be evaluated. One is the energy saving. Second is the evaluation of the program or process. Third one in the market effect. So the effect of energy efficiency program on suppliers and customers. For example, if the direct example is the LED program. Before the Ujala program, the cost of LED was something like 300 to 400 rupees. It is came down to less than 100 rupees or less than 60, 70 rupees. So that is the market effect. Similar way, in future, probably air conditioners are, the usage of air conditioners are increasing every year. So if Bureau of Energy Efficiency comes with a program, they procure, say, 10 lakh air conditioners from in a competitive bid, the price of the air conditioner maybe comes down drastically, because the manufacturer will have a clear visibility. Okay, there's a demand for 1 lakh or 10 lakh ACs. So they will be able to put the plant, they will be able to optimize the cost so that that cost will come to the consumers. That is a market effect. So for verifying the energy saving, there are international protocol called IPMVP, or there is a protocol, ISO protocol is there, the standard is there. International Performance Measurement and Verification Protocol. That's an internationally accepted protocol for savings verification. There are various methodologies for verification. So we'll see that in the later stage. Then large-scale data analysis. It can be the load pattern variation. And third one, deemed saving. Deemed saving means when you are distributing a 10 watt LED and it is supposed to replace a 60 watt incandescent lamp. So we can directly say 50 watt savings in each lamp. So it can be directly deemed as a savings. See, for example, when you distribute 1,000 lamps, 1,000 into each household, typically 3 to 4 hours it is operating, then we can calculate 50 watt saving into how many hours, into number of lamps distributed. So that is called deemed saving. That is also one of the ways. Second, the process. Processes depends on surveys. Surveys may be sample-based surveys to checking, okay, how many hours it is operating, whether people are installed that in, say, general or the in bedroom or in a area where, or kitchen or a area where it is more like more time it is operating. So these type of input can be taken from the surveys. Then second one, in-depth interviews, the program design. Basically, it is basically the evaluation of the program, not the savings, the second part. Third one, in the market effect, it can be self-reports, expert judging, or historical tracking, all can be done in this evaluation. So this is the workflow of reporting, planning, implementing, and evaluating the energy efficiency programs. So basically, plan the program, it will have projected saving, implement the program's claimed saving, and evaluate the program. So evaluated saving. So in all the three cases, any project, initial stage or the study stage or the project stage, it is a projected saving. Then during the implementation stage, it will be claimed saving. Then further, it will be the verified or the evaluated savings. So basically, first part is to basically decide how much investment is required, who will invest, what is the ROI, if there is a funding is required. This all will come from the initial part of the planning the program. Then in the planning stage, objectives and metrics. For example, what is the objective? Whether the objective is to shift the load. You remember we saw a load curve. Whether the objective is to shift the peak load or the objective is to reduce the energy, overall energy. You remember it is a strategic reduction. What is the objective we have to clearly understand. Then based on that, the matrices should be defined. Then it should be also defined what is the evaluation approach, how we do the baselining, how we'll verify the savings, how we'll collect the data. So this all will be planned in advance during the planning stage so that all the risk also to be identified. Since once we invest the money, we have to ensure that we are getting the expected outcome. So we cannot say that, okay, this was not expected or the risk was not evaluated. So it is important to do this planning by experts or who is having experience in that area, so that it will be able to evaluate various risks and also will be able to suggest the mitigation methodologies, how we mitigate that risk. Then in the implementation stage, one is the verification. We have to ensure that what planned and what implementing is matching. And we have to evaluate first year gross saving or net saving. Then we have to evaluate what is the lifetime saving. For example, when you are putting an LED lamp, it is not only one-time saving, it may be last for, let's say, 5 years or 10 years. We have to evaluate what is the lifetime saving. Then other benefit, for example, by replacing an energy efficient technology, we got other benefit of maybe CO2 emissions reduction. Or there is a capacity release. For example, we are replacing lamps with efficient lamp. So overall kilowatt requirement is also coming down, or kVA requirement also coming down. So that with existing capacity, we may be able to give maybe another 100 houses the power. So that is non-energy benefit. Then we have to determine the cost effectiveness and finally reporting evaluated savings. So the savings evaluation typically done by, if it is an IPMVP protocol, there are certified measurement verification professionals. They do the verification of that because they are trained for verifying and creating the methodologies. So these were the savings determination approach. One is measurement and verification. So typically this is applied for project level and means to determination of the gross energy saving at individual site or project. So there are multiple methods, or it can be the combination of engineering calculation, statistical analysis, or computer simulation modeling. So for example, it is a acceptable method to do computer simulation, like using like eQuest software to evaluate what is the savings by doing an energy efficiency retrofit in a building. So that is a approved model. Then second, deemed savings we seen earlier. So we may install one device. It may be one LED lamp or one fan. Then what is the savings in that? Then maybe multiply with the number of lamps, then consider that as a deemed savings. So which may be applicable where we have large scale deployment. For example, we have a number of lamps distributed to thousands of people, then it is not possible to do individually verify the savings. In that case, we can use a deemed savings. And which may be able to back supported by the energy consumption in the grid. Then third one is the large scale consumption statistical analysis with use the comparison group. So it may be implement one of the area and compare that with non-implemented area. Then we can do the result comparison. So that is also one of the standard methodology. So every measurement and verification adds value by increasing acceptability of the energy performance and energy performance improvement result. And it is also used for increasing the energy saving. Then second, document the financial transactions. When you're talking about financial transaction, it may be many of the cases the payment is directly related to the savings achieved. So it is also important to calculate or record that savings accurately with predefined methodology, so that every month it can be paid. So we'll see that in the later stage how it is done in an example when we see the example. Then it also helps to improve the engineering design and facility operations and maintenance, then manage energy bills. These are the MNV cases. So a definition of MNV is in the process of quantifying savings delivered by energy conservation measure. Energy conservation measure is any project or activity which actually reduces the energy consumption. So there are protocols or guidance documents to help develop contract language because it is technical in nature, so that how every measurement is done, what is the frequency, what is the conditions, what parameter to be measured. This all will be recorded in M&V plan. Then it is also important to maybe future adjustment of the saving. For example, there is a specific scenario happened. We can consider a scenario, some of the energy conservation project were implemented in a panchayat. Considering a normal scenario, then what happened? There's a COVID came. During COVID time, most of the people were staying indoor. So the energy consumption actually increased because more people are there in house for a larger duration. So in that case, even though the suggested ECM may be help to reduce the energy consumption, but there's a change in the scenario. So this type of change in scenario needs to be captured in the M&V plan. So that is the reason it was told, okay, this M&V plan should be properly designed and recorded. How strong the plan, it will be easy to complete the M&V or the success of the project. Otherwise, later time, in the stakeholders will not agree in the M&V plan because the person who is paying the bill tell, okay, my energy is not reduced, it is actually increased. Then the implemented person will tell it is because you are utilizing for more duration. Then it was not captured in the M&V plan. Then there is an argument and issue. So this is the savings. There's a baseline energy consumption. It may be 1 year period, it can be 1 month, or it can be even 1 day. So baseline period, what is energy consumption? Then reporting period, this is the green color is the measured energy consumption. Then there is an increase in production also. So this is the measured energy consumption. Then because of increased production, it was supposed to go in this pattern, the blue line. But due to the implementation of the energy conservation measure, we are able to maintain at much lower condition so that this area will give the energy saving. So it is not only the baseline period minus reporting period energy. You can see here clearly plus or minus adjustment. This is very important area, plus or minus adjustment. How we are defining that adjustment, that is how the success of that M&V plan. So this is the M&V process. Establish and document the M&V plan. Then data gathering, it may be using energy measurement, elimination measurement, operating hours measurement, temperature measurement, etc. Then based on that, we have to do the implementation of the energy conservation measures, then analysis, then report the M&V result and documentation. And how long it will record, it depends on the project. So some of the project where I worked, it was done, the M&V done for every month for 3 years period, where it was a large project. And some of the project currently doing, it is for 7 years. The contract is for 7 years. So every month there's an M&V. So the duration can be based on the project duration. Then there are multiple factors driving energy saving. One is the performance or the energy efficiency. So the performance of the equipment may be improved, but second, in the operating hours. If you reduce the operating hours, that also results to the reduced energy consumption, and improvement in the performance also results by energy consumption. When we do a combination of these two, we get maybe maximum energy consumption, energy reduction. So it is important to capture all these parameters so that we can accurately evaluate what is the energy saving achieved by implementation of a specific energy conservation measure. So it is quite important. We have baseline energy consumption. You can see here this line. Then done a retrofit. For example, it can be a very simple lighting LED light. In the baseline period, maybe the operating hours was this much. In the proposed case, we installed an LED lamp along with an occupancy sensor. So the operating hours also came down. So overall energy consumption reduced to this white square. Then in the earlier case, we can see the what out this colored portion is the saving. So in this, you can see that the one key parameter is the energy consumption of power. Second is the operating hours. So when we have either kilowatt, or we can measure the kWh directly, which directly gives the same. So we have to decide, are we going to measure in the kilowatt, then multiply with hours, or are we going to directly measure the kWh? So this is the sum of the protocols. IPMVP protocol, International Performance Measurement Verification Protocol, which is most commonly used protocol. And second is the ISO standard, Energy Management Systems Measurement and Verification of Energy Performance of Organization, General Principle and Guidelines. In addition to that, there are country-specific methodologies or standards. For example, in India, various government schemes, for example, the PAD scheme, they have some of the, it is also, we can say that it is in line with the IPMVP protocol, but with a slight modification. So it can be the country specific, some of the standards also are available, but these are the most commonly used protocols and standard for measurement and verification. So there are 4 options of the measurement and verification. One is retrofit isolation or key parameter measurement. For example, in this case, this will help to reduce the measurement cost, but it is having some uncertainty. For example, this is applicable for a motor replacement. We are replacing a motor or a pump with a high efficient pump. So the measurement may be done, what was the power before the replacement and after the replacement, then multiply that with number of operating hours. So it is a one time, easy to do the measurement. And the second part, whether how many hours it is operating, that is only a consideration based on the historical data and or agreed value. Second case, it is a retrofit isolation in that all parameters are measured. For example, when we have a lighting retrofit in a building, along with occupancy sensor or a motion sensor, so it becomes more complex. In that case, we may have to measure the energy consumption in the lighting feeder. Then what was the energy consumption for a specific period, maybe a 1 month or 1 week before the implementation, then measure the after the implementation. So that here we are measuring all the parameters, all the critical parameters. Or in this case, it is a kWh. kWh is a kilowatt into hour, so that both are actually coming in the kWh. So it may be same for motor replacement or variable frequency drive or variable speed drive. So variable speed drive typically apply in a scenario where the load is varying. So in that case, the frequency of the drive also varies. So the savings vary with respect to time. So in that case, to get accurate saving, it is important to measure the energy. Or third one is another example is a renewable energy generation. That also depends on if you consider solar, the cleaning of the panels, orientation of the panels. Even we may consider orientation may be constant during the installation, but cleaning makes a difference. Or the reliability of the inverter, say one inverter got down, then it won't generate. So in that case, we have to have in the all parameter measurement. And option C, it is a whole facility analysis. For example, there are multiple energy conservation measures implemented in the same facility. For example, we have light replacement, some of the retrofit in the HVAC system replace the normal AC with 5-star ACs and other energy efficiency measures also. In that case, many of these measures have interaction with other measures. For example, when you replace the lighting in an air-conditioned space, your HVAC load also will come down because the heat generated by the light is coming down. So in this case, we can have whole facility analysis, or we can say it is the utility bill, the electricity bill we can compare with previous as well as the current scenario. So this is applicable when you have multiple energy conservation measures applied to a same system. Then fourth one is the calibrated simulation. So in that case, for a new building, we have to evaluate, okay, what will be the savings we will achieve by replacing a standard efficiency motor or a standard efficiency pump with a high efficiency pump or a high efficiency chiller or air conditioner. Then this can be done with calibrated simulation. In calibrated simulation, every hourly data, like weather bin data, what is the operation data for 8,760 hours, data is fed into the system, then accordingly it is modeled. How many hours it is operating, then it is compared and given the result. So these are the 4 methods. So till now, any questions? Anybody having any question up to this point? So we have covered basically what is demand side management, the requirement, demand side manage, various programs under demand side management, and how to do the M1B or evaluation, measurement, and verification. If anybody having any question, if you can just put in the chat box or you can ask. If not, we'll go ahead. So I have mentioned I could get chance to work on various municipal demand side management program. So some of the studies were done like large cities like Cochin Corporation, Trivandrum Corporation, these type of cases. It is including the lighting, then what is the pumping system, then municipal buildings, all these are studied, then identify where is the opportunities for energy conservation reduction. This was some of the pilot studies done in like 2010-11 period. During that period, the cost of the LED was quite high and the return of investment was very high. Typically, it comes 7-8 years. Then later, in the LED price, everybody knows, okay, the price has exponentially decreased. So that now it become, and earlier in the reliability of the LED lamps were not that great. So later, in the LED lamps were quite common, the prices came down. So in many of the municipalities, the large municipalities were implementing LED project. LED project, it is not only the replacement of LED, but it also having control system, central monitoring system, and also there are strict service level agreement. So you know that typically every municipality, every village, when you have a street light, half of the lights are not working. But when this type of project, this is under smart city project, in the investor or the concessionaire who is implementing the project has to ensure that the lights are on. The 99.25% in some of the cases should be live or on during any day of the time, whatever the allocated time. Second, if there's a fault, it has to rectify it within a 1 day. So that is the timeline it is given. If it is not happened, then there is a penalty in the payment. So this was a project which is done in one municipality, it's a large municipality in Karnataka, Tungur municipality. The aim of the project was the replacement of all the conventional lamps, and there are few LED lamps with new LED luminaire. That was one of the purpose. Then second, in the installation of a centralized control and monitoring system to aid simplifying operation and maintenance service and higher uptime. That means there are multiple lighting feeders. At any point of time, we can see that how many lamps are on, which lamp is off, which is blown out, how much energy consumption, and this visibility to the municipality. Then third one, to have the better illumination in the roads and to reduce the CO2 emissions and uniform illumination throughout and improve the quality of the life. Then the preparation of the CCMS dashboard, centralized control and monitoring system dashboard, and the automated operation of street light. So basically automated operation means in the summer and winter, the switching on and switching off can be adjusted so that we may get some savings of say 15 minutes or 30 minutes based on the season. So this is all can happen by using a CCMS, central control monitoring system. So this starts with an inception meeting, then data collection. Data collection means each lamp, what is the type of lamp, including a GPS location, image, with the photo of the fixture, whether it is working, not working, this all data is captured. That means the baseline data is captured thoroughly with GPS location. That means if there's a lamp in one particular street, that photo is available, exact GPS location is available. So no one can actually do any malpractice. So when someone can check, okay, this particular location, this lamp is there or not. Then this is done using a field survey and mobile devices, and it is all the data is captured. And based on this, a detailed project report is prepared. A project report that is including what is the energy cost, how many connections are there, how many metering points are there, how many are actually working, what is the maintenance cost. All this data is captured, and the final report is submitted for approval to the municipality. Then municipality will allocate through a tendering, they will select a company for implementation. So that was the methodology. So this was the summary where they had almost 35 watts and 1,542 switching points, 29,609 poles with 39,868 number of lights, and 361 poles had without any light. Then you can see here number of lights installed was 39,868. Number of working lamps was 23,913. 15,955 lamps were not working. But typical energy data or a system is like if there are 100 lamps is installed, for 100 into 10 hours or 12 hours into 30 days, a calculated energy bill is generated from the BESCOM or electricity company, and that much amount is paid by the municipality. So ineffectively, without almost we can say that 30% of the lamps were off, but still they were paying a huge amount. Then second, we have to also see that there's a illumination standard with respect to the road category. So road categories group A1 to E, A1, A2, B1, B2, D, and E. So based on this, what is the minimum average illuminance required at a road surface? And there's a uniformity ratio. What is a minimum to a maximum? So this is also standard is there so that it gives a uniform lighting. It will not create any glare effect. So based on that, in the previous scenario was, it is not in the type of lamps were not selected based on the lamp category. It is something like arbitrary. So what is some cases the large high power lamps are installed. Some cases even in narrow loads, high power lamps are installed. So when you see here secondary roads with the light traffic, it is 4 lumen, 4 lux is required. Only very low illumination level is required. When you talk about 4 LEDs, and we have to understand that even at 2 LEDs we can see and we can read. It is not very high level reading, but we can read the boards and all. That means LEDs level is even at 2 LEDs. And you can see here, this is the summary where almost 22% was 250 watt sodium vapor lamp, then 28% 150 watt lamps, and 35% 36 or 40 watt lamps, and 11% 65 watt lamp. So here, when you see majority of the lamps are at high power, so almost 50% comes to 150 and 250 watt with the sodium vapor lamp. And because of better color of LED also, you get better illumination. So to various categories. And there were some of the LED also installed. So you can see that is 72 watt, 90 watt was installed. Even B2 category also 45 watt lamps were installed. Then when you see, okay, a municipality, you can see here the energy consumption was 2 crore 66 lakhs energy consumption kWh, and which is accounting 6 megawatt, 6,077 kilowatt load. And the electricity cost of the LED plus conventional, altogether there was a maintenance cost of 3 crores. There was a maintenance cost. Even after paying 3 crores, you could see earlier 15,000, more than 15,000 lamps were not working. You know that how typically this scenario work. I need not explain how it will work. So maintenance payment is done, but lights were not working. Now, based on the calculations, we could get an estimated energy saving of 73%. 73% savings in the annual energy consumption was possible in this specific case. I'll explain this in the coming slide. So I'm not explaining individual line item. So number of three-phase energy meters, before what was the consumption, the connected load, everything is calculated. Then there are two considerations done. One-to-one replacement. For example, if there is a 250-watt lamp, for 250-watt sodium vapor lamp to get the equivalent amount of illuminance, what is the wattage of the LED required? If you do a calculation based on that one-to-one replacement, we could get 58% on the conventional lamp. But there are some LED lamps which is not going to give the savings. So overall savings was, and there are additional lamps. You've seen that, okay, almost 15,000 lamps to be added also. So 54 was overall savings with one-to-one replacement. But based on the national IS code, IS standard, with respect to the type of the load, the overall savings only conventional lamp was 78%. That means a large number of roads, even very low wattage LED could give required illuminance. Then overall savings was 73%. And capital investment was 22 crores. And with the overall, since first year capital investment, then there is a finance cost, then maintenance cost, all those adding up, it was 28 crores over a period of 7 years. So this amount was finally given by, there was a program called the performance guarantee scheme from the central government. Under that, the ESCO is the company who are actually implementing the project. They got a partial loan and they implemented it. Then what the ULB is paying, you could see that previous case, it's almost 18 to 21 crores was the annual energy bill. Annual energy bill was 21 crores. In proposed scenario, a third party will invest. The municipality is not paying anything upfront, but they will pay a monthly EMI of 65 lakhs if they get a minimum savings of 54%. That means if 54% savings they get 65 lakhs as an EMI. So the company is invested total amount and municipality will give a monthly EMI of 65 lakhs. So in a year, they will pay 780, almost 7 crores amount to the investor or the third party who is invested them for the project. There is no maintenance, and in the complete illumination is ensured. Uptime of the lamps were ensured. And there are some incentives also. For example, in this case, it was estimated they get 73% savings. If they are able to achieve 73%, the investor will get 71.23 lakhs. If there is a shortfall of saving, so up to 40%, there's a reduction. So if it is 40%, they get only say 45, 40 lakhs rupees. Less than 40%, they won't get any money. The investor won't get any money. So it is quite transparent way of calculation, and there is a third-party verification of this saving for M&V. There's a protocol that everything is given in the report. So based on this, it is running. This project was done in 2021. Almost 4 years it is running. It is for 7 years project. So municipality is gaining benefit. Almost 60% of annual energy bill they are saving, and every year there is a 5% increase in the charges to the outflow. So because typically energy cost is increasing. So this is how the project is done. You can see here almost 6 megawatt load. Out of that 73% reduction in the energy consumption. So there is a demand reduction also. So for almost 5 megawatt, more than 5 megawatt was actually able to release or from the system. That means demand was able to reduce in the system. So this is typically happened. Similar project is happened in multiple cities. This is one type of a demand side management. Similar way, other projects are like a municipal pumping system, where a third party will invest for the municipal pumping system with a high efficient pump, and from energy saving or reduction in the energy cost, the municipality will pay the amount to the investor. So this is one of the project. So here also measurement verification is done actual based on the energy meter. So there was energy meters which is having a dashboard and it will go to various levels. In case of any specific line is not working, they get SMS messages, etc., so that it can be addressed immediately. Okay, so with that, we have almost 20 minutes time for the question answer. If anybody is having any questions, we can ask, or if any of the specific session or specific slides, if you like to revisit, I can do that also. Or if anything other questions related to this also, I may be able to, I can try.